The original thing. There we go. There you go. It's there.
Okay. It's someone to pick up. Samba. So this is the activity we like to do. We like to test it. In this case, I think this one is a useful thing because it's going to talk So if someone was standing here and talking, the audio won't come to this one. What I mean is, I get like stressed out. So that is so you're on the Zoom and the Zoom output set, right? Testing 1 2 1 2 2.
Hello. Okay. So how loud should I shout? I'm testing. Can you hear me? Is everything okay? Is it working? It's not terrible. Hey.
You should be in a good setup, man, because if you're up here, there's nothing else that you need for example. Comes in this case scenario, reasonable changes. If I do like it's a good, you have to like put something like. Do you mind if I say about anything happens? So that is someone needs to review this. I guess. I think whether
once these once even become the welcome, you need to just move this laptop and put it on that table there and you share your laptop.
yeah, okay. Yeah, I mean the other option, I suppose the other option is if we just push that slightly up to the side, then we have the like a little seat at the table for the person who's presenting.
Well, I
Worry about not being something.
and put it on that table.
Okay, that's fine. Yeah. But can anyone? Have you made like so when it's the person's spent over, you said okay, but and it'll pop up normally with just this person permission to take over. So the plan now is, it didn't sound terrible, to start this TV has a but starting next TV, hopefully everyone in the outside of the video, and for purposes of the room leaders. And that's how you get rid of this. Like drive it off the screen somehow.
No, that's fine, that's fine. Okay, so basically what we do is to even finish the welcome intro. Move this entire thing down to there, and then.
We should just that's even myself, right? Okay, so hopefully everyone on the internet on the other side of this video. Welcome to London. Finally. We have some great talks tonight. Open policy agent. I'm really looking forward to a little bit of security, interested in the runtime protection, and we'll have a little break and then on storage. Okay, as usual, we are at #CloudNativeLondon, and we are a strong, open, diverse developer community dedicated to cloud native platform. Stephen just signing in for Cheryl. I believe Cheryl has had baby, and it's happy and bouncing baby still. This is us for today, and I think we have someone here, the word from our sponsors.
Hi everyone. I work at Tree, which is the venue where we are today. If you've not come across this before, we're a workplace provider. We're based across London, across Dublin and Manchester. And we provide a home to the most innovative tech startups in the ecosystem. So hopefully you're members. If not, check us out. This hub in particular is our AI Metaverse Web3 hub. So if anyone's working particularly in those lines, it's got a really cool ecosystem here, but we're based right across London and growing with another couple of sites at the end of the year, more for 2024. So exciting times for us. So RealDB, I'll give them a shout out. They're one of our members. They do really cool stuff with databasing. If you're not on them and you're a developer, please do check them out. And they have a very exciting conference lined up next week. So RealDB 1.0, you'll find the signage all over, and they've helped to sponsor tonight. So a big thank you to them. I'll do the really boring health and safety stuff. So if the fire alarm does go off, we don't have any drills planned. We will need to evacuate, and the lovely Asuka will be able to show you outside to the assembly point around the back of the building. There's no smoking on the terrace, unfortunately. So if you do smoke or vape, please do just pop down to the street level, and you can do so there. Leaves just through this door, refreshments at the back. That's probably everything. If you want to know more about Hopper at any point, come and chat to myself or Asuka. Check us out on our website. But I'll shut up now and let you get on with it. Thank you very much.
I would just say a big thank you to our other sponsors, Systig, Mattermost, started. And if everyone wants to join the poll, we have some questions, and the poll is actually working. Is this your first time at Cloud Native London? Everyone's been helpful. What is your job title? We have no signal in the building to be able to.
If anyone needs the Wi-Fi, so this is the
Architects, application developers. Sorry. Someone who doesn't want to be called an application developer. So we have a nice mix of skills and interests. How are you using WebAssembly today? Stateful services like databases in K8s. I certainly do. Yes, no. That was easy for my own interest. Is anyone doing that in production? I do it most of the testing. So, have a few hacks. The audience is good. In the statements. Really interesting. I think in our service in production. For some people not. That's occupied. I got told off for this last time. My selfie skills are bad. Oh. Thank you. Yes, we have more speaking slots. I think there was someone kept, but there were slots coming up for the next one. We've not got any more. But if anyone wants to talk, it's a brilliant thing to do. Please click on that website. Everything's responded. I think we're running late, so I'm just. Okay, so we. Okay, so we'll start. Yeah, let's go for so I think you move this. Yeah, let's move this. And if you take over, hopefully, it was better. And so this. Or you have to stop sharing. Otherwise, it won't let me share. That's true. And I stop sharing. Hopefully, audio will still back. I think so. That's not needed. So, I'm still hoping if I sit anything slightly that way, it will pick up. Okay, it will hit me. The camera's coming from that one. From that. I mean, they can see me. They can kind of like this. I mean, I can put my camera on as well, but I think it might then pick up more space. I don't know how we get rid of. Do we want to try and get rid of this on the side, or? I don't know. I mean, okay, just go. Sorry. I mean, I think hopefully people will just be able to see. Okay, hello everybody. I'm Charlie. I'm going to be talking about WebAssembly and OPA, Open Policy Agent. Yeah, it doesn't look like a lot of people are using WebAssembly at all, so I hope this will be educational. I'm going to share some links throughout the talk, and if you miss any of them, if you scan this just now, they will all be available at this URL afterwards. So yeah, I'm Charlie. I work on the developer relations team at Styra. Styra is the original creator of OPA, Open Policy Agent project, and it's now a CNCF project. It's a graduated CNCF project. Styra have a few enterprise products in the sort of policy as code space based on OPA. Some links to them here if you're interested to check them out. There's a kind of policy control plane called Styra DAS for managing the policies, and we also have an enterprise policy engine called Enterprise Open. Feel free to ask me about them afterwards. So yeah, I'd like to start by posing a question.
what are policies, or what do I mean when I say talk about policies? And I'd just like to challenge what we might be thinking about. So the kinds of policies that usually spring to people's minds are the kind of SaaS or organizational rules that are encoded in various tools that we use throughout the day. For example, only admins are allowed access to make changes to a particular data set or a particular set of documents. Users in a particular department can look at salary information. Just some examples of kinds of organizational policies that we're all probably very familiar with. But I suppose I'd like to get you thinking about a sort of broader definition of policy. So I don't know whether anybody has taken a plane to be in London today, but at least in the Western world, most planes don't have a row 13. So when you're handling bookings for planes, you would want to make sure that nobody's trying to book a seat in row 13. That's an example of policy as I understand it, as I see it. This is a bit of a fun one, I think. When I first worked on this talk, it was a different time of year, but there is a product which is sold in the UK, and the product can only be sold between January the 1st and the first Sunday after the full moon that occurs on or after the spring equinox. And I wondered if anybody had any idea what that product might be. Correct. Easter egg. Yep, that's correct. It's the sort of when you will find Easter eggs on the shelves in the UK. So my main point here is that when you broaden your mind to your definition of a policy, it's kind of policies are all around you when you're working in the modern world or in a modern business. So in order to make use of these policies or to enact these policies, we need to have something which is doing policy evaluation. And in a generic sense, this is the model, or this is how I think about policy evaluation. So you've got at some point in your system that is the policy enforcement point where you are enforcing a policy decision. So is that person allowed or are they not allowed? Somewhere else in your system, it may be the same application, there's a point where the policy decision is being made. So that's where the information that's needed to make a policy decision has been provided, and a decision needs to be made based on some policy logic. And then the decision result is returned back to the policy enforcement point so that can be enforced. And that policy decision is enforced based on some extra information, including the policy logic, but maybe some extra data as well. So just as an example, you might have a web application that receives a request from a user. The user is coming and uses information about who they are and the IP address that they're connecting from is provided to the policy decision point. The policy logic might say that that user is normally in this country, they've arrived in a different country, and also some extra data about the country they were previously in is maybe made available in the policy decision point. And then the policy decision point makes a decision that says, oh, well, actually, we're going to re-authenticate this user because they've moved since we last saw them. So that's the kind of general model that I think about. So within a single application, it would look like this, where, for example, you might have a web endpoint which is processing requests. You might have some authorization module in the same program. And these two parts of the code base speak to each other in order to enforce and make policy decisions. You might, in the same application again, have some policy logic either encoded in a high-level general purpose programming language and bring in data from any data sources available within that application. So you may also be working in a distributed system where policy evaluation looks slightly different. And actually, these policy decision points and policy enforcement points are actually different services in your infrastructure. So there might be a business application which is responsible for selling widgets, making money in some way, but you might have many different services that are making money in many different ways. And you might offload some of the policy and policy decisions and making of policy decisions to a different service. And this is commonly how Open Policy Agent is used. But in that case, it can operate, for example, as an authorization server. Authorization or certain types of authorization are policy decisions. So this might look more familiar depending on the world that you're operating in. And that's where that distributed model of policy evaluation is often how people come up against Open Policy Agent, which is a project that I work on myself. So what is Open Policy Agent? It's a CNCF project. It's graduated. It's commonly used in the sort of infrastructure space, but it's meant to be general purpose. It's meant to be suitable for use for application authorization, as well as infrastructure and compliance and auditing use cases and so on. So if you're already using OPA, feel free to scan that and update the page so we have the people who are using it. Yeah, maybe you've heard of it, maybe you haven't. I'll try and give a brief overview just now. So I like to think of Open Policy Agent project as being these things, in addition to the community, of course, is a domain-specific policy language, which I'll go into next. A policy server, which you can run if you want to run policy decisions in that distributed model. But also, if you want to bake a policy decision engine into your application, you've got various different OPA-based ways of doing that too. And today I'm going to be talking about the WebAssembly. That text is maybe quite small, but there are various ways you can use the WebAssembly modules that are generated from the policy language in all sorts of different applications. And you bring all of this together and you get OPA. And I think it's really the domain-specific language, Rego, which brings together all of the different use cases of OPA. So I'll briefly go over that just now. So here's a very simple policy. It's about the most simple policy that you can express in Rego. I have a package, which is an authorization package, where I have a rule. The rule is allow, to allow or not to allow. And by default, this allow rule is false. So unless this evaluates true, the allow decision will be false. So if I provide some information saying that the role is admin, it will be allowed, but any other role would not be allowed. And you can imagine implementing policy like this in almost any programming language that you've ever worked in, and it's maybe doesn't seem that powerful, but I'll try and explain why I think it is. So here's an example of email validation. Show of hands, like who's implemented email validation in their time? Like I know that I have. It's something that you're hopefully familiar with. This is what email validation might look like in Rego. So you would have a series of rule or a deny rule, which is made up of a series of rule heads where you can describe different factors that you want to validate on an email. You can judge me for my email regular expression and tell me about a better one later on if you'd like. But here are some rules. This is how you would validate an email against a regular expression. You can also do things like make sure that you're not allowing certain domains or whatever. And the language looks like this. You've got various built-in functions that make it easy to describe small nuggets of policy as you build them out. But I want to show a more involved example of a policy that I think is interesting, which is based on some hierarchical data, and it's similar to what I will present in a short demo later. So we've got an org chart, which looks a bit like this. You can imagine a similar data structure for your organization. And I'm interested in making decisions about whether a particular business unit is allowed to request access to a particular resource. So using this org chart data, I can create a graph of nodes and edges based on that. So using this, I can select a business unit within the org chart, and I can, using the managed by field, which is set in the original data set, I can find all of the edges that go from one business unit to another. So I can build a structure that looks a bit like this, where I've got sorry, my screen is quite small. I'm trying to make it a bit bigger. But so the boss has edges going to developers and human resources. Developers have edges going to interns and so on. So because the interns are managed by the developers, there's an edge there. And the idea is that we can implement a sort of aggregated hierarchical model of permissions using this structure. So now that I have the graph data, I can find business units again that are present in the org chart. So that's boss, human resources, developers, interns, and I can, for each one, find all of the reachable, following the edges, use the graph.reachable built in, and find all of the edges that for all of the other nodes in the graph that I could get to. And then I can, from all of those reachable nodes in the graph, I can aggregate up their access that is available for each of those other business units. So just to show you what this intermediary structure looks like, the boss gets aggregated access to all of the different requestable objects in our system, but interns are only allowed access to, for example, the dev environment. And so that means that I can now write a very simple allow rule that looks up data in this structure. So it says, is the requested item, is that present in the org chart permissions for the business unit that's supplied? So if I now evaluate allow for the developers, are the developers allowed to access the salary information? The answer is false. But if I submit that same request as the boss, the answer is true. So hopefully that's the intention there is to show a slightly more involved policy and perhaps a policy that would be less trivial to implement in a language that you're maybe familiar with. And I showed that using the open policy agent playground, which is a fun way to play around with the language and try out different policies that you're working on. We've just a little plug for something we're working on. We know that people sometimes find the language hard to write and hard to get their head around. We've been working on a linter recently. It's called Regal. The idea is that it will help you make your Rego code better. I think it's a pretty good tool for people who are learning OPA and Rego, so I'd encourage you to check that out as well. So, but yeah, I'll get to it. It's possible to use Open Policy Agent to generate WASM modules from this Rego language. And that's what this talk is really about. And so it's about running WebAssembly within an application. We're talking about an authorization module within your application, running the policy decisions using WebAssembly. This has a few benefits. It might allow us to make very fast policy decisions, but WebAssembly is very performant, but potentially we're able to avoid making a hop to another service. It can save us the round trip time of making that request. And it brings the policy evaluation and the policy decision point closer to where we want the feedback for the user, which can lead to a good user experience. It might allow us to standardize our policy logic across a whole series of different applications. So if you have some business logic that maybe it's implemented in your JavaScript front end, but it's also implemented in your Go backend, you've got two implementations of what's the same policy, or in effect the same policy. And in a large enough team, or in many circumstances, this leads to some kind of drift between how that policy is actually enforced, or exactly the definition of that policy in different applications. So running precisely the same WebAssembly module representing the policy in different applications could give you some standardization. For some data-intensive policies, running the WebAssembly version of the Rego code that represents the policy, that could be more performant than using OPA as a server or using the Golang implementation of Rego. So I'm going to present a short demo now. The demo architecture consists of 3 different services. I've got an example JavaScript front end, which talks to a example Python backend, and they talk to each other over HTTP. They both are able to run the WebAssembly version of my policy. And I have a demo controller, which allows me to control the policy, what the current content of the policy is. And the policy is refreshed by each of these applications when I click a button. I'll show you that now. So this is my demo application where I configure the policy. At the moment, the policy is empty other than some name of the package and some sample imports. This is the server. At the moment, there are no bookings. And the demo application is for booking train tickets. So this is the idea is that this is the very primitive form that a user would see when they are booking tickets. So I've got a few different options I can fill out here, but just to show that there's currently no policy running, I can click book tickets, and it says okay at the bottom, the booking has been accepted. And if I go and have a look at the booking server, we can see that an empty booking has made it through to the booking server, has been persisted in some way. And obviously we want to enforce some validations here at this point. So the first thing that we're going to validate is a nice, simple one to add. And we're going to make sure that people are booking tickets for at least one passenger. It only really makes sense to book tickets for one or more people. So that seems like a good thing to enforce. So back over here in the JavaScript client, I can click reload policy, and now my JavaScript client has, from the demo configuration application, has loaded in the WebAssembly module and will now enforce the WebAssembly policy when I attempt to submit the form. So I've selected 0 passengers still. I click book tickets, it says that the result has come back from WebAssembly, and it's telling me that I must have at least one passenger. I can go and update that to one passenger, click book tickets, and the booking is now being accepted as passed. But this time it passed the policy. It passed the policy that I'd implemented, which was only validating the passenger count. So let's continue to add some more things to our validation. So we can start with some email validation, which we've all done lots of times, I'm sure. But it's a good example. I'll just quickly update this. So we're going to make sure that we're going to basically deny any submission, where the regular expression that we provided here is not matched by the email that the user submits. And similarly, we're also going to deny example.com email addresses. So if the email address that's been submitted ends with example.com, we're going to deny it. And quickly reload the policy just to show that it's working. It says here that the email must match this regular expression. All good users of all web applications understand regular expression syntax, which is great. So they know exactly what to do when we show them a regular expression. I'm going to put in an example.com email, and we'll see that I'm now told the example.com emails are not permitted, and I'm going to go and quickly put in my actual email, and we should find that this time I'm allowed to book my tickets again. So we've now validated the passenger count and the email, but we've still got some other things we want to make sure are correct. We want to make sure that when users are selecting where they're traveling to and from, they choose valid options here. So empty or missing departure and destination stations, we don't want to allow that. And we also want to make sure that the journey makes sense. Let's write some policy to make sure that that happens. Here's one I prepared earlier. It's again.
Just sorry to disturb. You know, in terms of one policy about saying that where you're traveling from or your destination, right? I mean, not from, from to and where your destination is.
Yep.
As you know, that booking agencies globally, they use the airport coding system, don't they?
Yes.
So LRH, if you learn meetup, and LH,
yep.
Like LH is another country. So the thing is that, would it be a good policy to just let the customer type the actual, what do you call it?
Let them type out the
type out the destination,
yeah.
Because I guess not every passenger will know the actual coding system, won't they?
Yeah, well, I suppose not. And there are. I mean, in case you haven't realized, there are various like user experience issues with perhaps how this form is laid out. Yeah. There's another question in the back, sorry. Yeah.
Yeah. If it fails the validations, run all of them, or basically you're going to get.
So each time the form is submitted, it runs the whole validation.
So I would get a red error for each one of those that fail.
Yes, that's right. Yeah, I'll show you that briefly. Yeah. Yeah. But to your point, like, yeah, there are various different ways that I could probably improve the form. If you've got some ideas for a future demo, maybe we can chat about it afterwards. But yeah, in this system, they choose based on the city's name. So, but I've written some new policy, and the policy makes sure that people aren't going to and from the same place. They must travel from somewhere that's different from where they left. We also make sure that they specify a value for both these two. I've chosen to write this in this way, but it's just making sure that neither of them are set to none. And then the more interesting one is that we make sure that the stations are within the same area. So, for example, Amsterdam and Tokyo you can't travel from Amsterdam to Tokyo by train. So we do some validation to make sure that if you're booking from Amsterdam, you're going to somewhere within Europe. And if you're going from Tokyo, you go to somewhere within Japan. And the way that we do that is by looking up the station areas in this stage structure here, and making sure that they're in the same area. So let's see what that looks like. So I can, I need to quickly load policy. And I can try booking my tickets. It says they must be different. And it also says that they must be set. So I'm going to try booking that journey, Amsterdam to Tokyo. Let's see if it's possible. Here it says the route must be within the same area. Amsterdam and Tokyo are in different areas. So I'm going to have to settle for Paris and make that booking. And that's been allowed. That's been accepted. And we should see that it's been accepted here.
And what about the traveling mode? So that would be, I mean, the ticket type would be a single or even a return?
Yeah.
It has to be one as a default, isn't it?
Yeah, well, I mean, at least the features of my booking system are quite limited beyond the validation. The validation for the fields that are there is hopefully quite robust, but you're right. Yes, there's no, I don't know, have like first class, business class. There's all sorts of things that I could definitely add. You're right, but yeah, this is just assumed to be a single. Yes. Okay, so we validated the route. That's great. There's one final thing that we want to validate, which is this fun, I think, way of describing how people should be booking seats on our trains. So the idea I had was that if you're making a booking for a number of passengers, maybe a group of people, you should be, for starters, booking the same number of seats that you have selected for passengers. So we make sure that the count of the seats that they've selected matches the passenger count in the form. But I also thought it made sense to enforce that people booked seats next to each other. So if you were booking a journey for 4 people, you didn't book this seat, this seat, this seat, and this seat. You would be encouraged to book seats that were next to each other. So let's have a look and see if we can understand the policy for this. So based on some data which describes the seat adjacencies, so seat 1 is adjacent to seat 2, 3, 4, and so on. For the record, this is seat 1, this is seat 2, 3, 4. And if so it describes which seat is adjacent to which other seat. And then what we do is we make sure that we only apply this rule if someone has actually selected their seats. Because if they haven't, then other rules will catch their mistake. We aggregate a set of the selected seats, so a set of unique elements rather than an array which may contain duplicates. And then for some seat in the set of seats, we find all of the reachable seats minus the seat itself. So we find all of the seats that are adjacent to it. And if the intersection of the reachable seats is there's no intersection or no elements in the intersecting set between the set of seats that the person has selected and the reachable seats, then we will raise an error message and say that the seat that's been selected isn't adjacent. So I've updated the policy. I will show you that this is running. So I can click book tickets again, and it says, oh, I haven't selected the number of seats, but we were going to do a journey for 4 people, so choose 4 passengers. And then I'm going to try choosing these ones, and then I'm going to choose this one over here. And it will tell me that seat 12 is not adjacent to other seats. And so I'm going to choose this one, and then we should find that the booking has been accepted. And if we look in our booking server, we can see that the seats have been allowed through. So, okay, that's great. I've shown you how to do the validation with WebAssembly in one place, but I haven't shown you how to do the validation on the server as well. And so if I just refresh this page, clear the form, there's no policy running anymore. If I reload the policy and submit an empty form now with our complete policy, we'll get a whole load of different error messages. We're getting error messages about the seats because I haven't selected enough passengers for the seat validation to kick in our policy. But we see there's a whole load of different issues. And we also see that they're all coming from WebAssembly. So they're all validations that came from this application, from the JavaScript application running in my browser. But if I refresh it again, and so there's no policy running anymore. There's also no policy running on the server. So if I click book tickets, it goes, okay, so that's fine, it allows through an empty booking. But what I can do now is I can reload the policy on the server, and we will now find that if I click book tickets again, the server has responded and said the same error message as before. The point is that the exact same validation is running in both places. So if for some reason it was misconfigured in one of the applications, I would catch it in both places, or I can respond quicker to the user when they're interacting with this front end plan. And it's exactly the same policy code. So it's all of this policy code that we built up over the course of the demo is running in both places. So yeah, that's my demo. I think I'm quite tight on time, but I did have a few other slides to talk a little bit about the history of OPA and WebAssembly. Are we okay just to go a minute or two over, or are we very, very tight? Okay, I'll try and be quick. So like this was a little bit of history lesson for me. I actually first started working with OPA in 2019, but the WebAssembly support predates that. There was this idea at that time that was very exciting that we could run WebAssembly in edge locations, and or in environments where it was challenging to run OPA as a sidecar, which is typically how people were using OPA until that point. And sort of early proof of concept. There's a blog post about it here, showing some good performance gains of compiling Rego to WebAssembly, sort of specifically with these use cases, edge use cases, CDN use cases in mind. And at that time, we had the first wrapper around the WASM modules for Node, which was the same one I used in my front-end application this evening. At the moment, OPA has good support for building and distributing WebAssembly modules policy and using them, both within applications using these various different official and community SDKs, but also within the OPA server itself. We also have a glass half full approach. We have good support for a number of the languages built in. Some of the language built-ins haven't been adapted to WebAssembly because we haven't had time and resources to do it. Some of them are quite dependent on the Go language, so challenging to implement or questionable as to whether or not we should port over the Go semantics into a WebAssembly implementation. And the SDKs provide ways for you to implement missing built-in functions if you want to, if you find that they're missing. So yeah, some of them are a bit uncertain and some of them just haven't been done. I'll skip mostly over these, but if you're interested in contributing to OPA and interested in WebAssembly, these are some issues which are quite interesting. They're either around expanding the use cases for OPA policy, which has been compiled to a WebAssembly module, or around extending OPA itself using WebAssembly. And this is an area of the Open Policy Agent project which hasn't seen a lot of attention recently. And if it's something that excites you, then new contributors in this area would be very welcomed. So yeah, as I said, any links that I've shared, you can get at this URL, charliegan3.com/talks/OPA-WASM, and that's available at that link. Have a look, and you can find me in these places. This is really small writing, but I'm Charlie Egan3 in almost everywhere. So yeah, do look me up if you would like to chat about this kind of stuff. And just one final plug. Don't forget to check out the new open source Rego linter. I think if you've struggled with Rego in the past, you might find this useful and interesting. It should help you write good policies. Thanks very much. Don't know how much time we have for questions. Maybe one or okay. Any questions? You here? Yeah.
Of the Rego language, is it a yes or it's kind of transposable?
So it's a domain specific language for policy, and there are I suppose like two main implementations. There's an implementation in Go, and then there's the WASM modules. So you can, or the WASM path, you can compile Rego to a WASM module, or you can evaluate it in Go. So it doesn't always turn into Go, or it doesn't always have to run in Go. Like I spoke before, that is going another way of running. We also have like the intermediate representation way of allowing you to run Rego in different languages if you implement a way of running the intermediate representation in another language. But that's a fairly like academic use case for it. Yeah, hope you answered the question.
Can you stop sharing?
Yes, sorry. I don't want to do new share. I want to do stop share. There we go. Okay. While you're getting set up, I can maybe take another question. Yeah. There was another hand that went up in that direction, but maybe it's gone down again.
What about
Okay.
right principles in OPA? How can what are the paradigm? I know I can import. I mean, I can see that even for simple use cases, it can get ready on relays too.
Yeah. So you can import different packages. You can write code in one file and use it in lots of different policies. Maybe you have a function, you can write functions to wrap up common functionality and share it within a collection of policy. We often like to talk about policy bundles, like have some shared block. Some part of the bundle is shared widely within a whole number of policy. We are interested in building a kind of package management thing. It's quite tricky, but it's something that we are thinking about. But I think that's your main. You can import from different files and put them in the live policy bundle, or even across different policy bundles. You have sure that they're available in
Can I do remote imports from my own repository?
Yeah, again, like that's what we're asking at least. Yeah, I suppose like the Star control plane, have an integration with Git that allows to pull the content from GitHub and turn it into a policy bundle, but yeah, we don't have like a Go mod dependency. There was another question, but I'm sure. No more questions. Yes.
And during your implementation, what were your really nagging sort of issues coming on?
Yeah, so I suppose the WAS modules that are produced by Opa are kind of their time, and there are various different kind of competing WebAssembly modules or formats or like ways to structure a WebAssembly module. And so it would be good to do some work to make the WebAssembly modules that are produced by Opa more. Like one of the issues I heard was running an Envoy. Like it would be nice to make. There's a lot of efforts to make WebAssembly modules more pluggable. It would be really nice to have a more modern module that's produced and to be able to use that in a more WebAssembly way would be really good.
Yeah, so basically having much more succinct.
Yeah, I suppose what I would like is maybe a more standard way of invoking these modules and passing and sharing functionality between them. I think that would have been. Yeah. Okay, thanks very much.
All right. Hi everyone. Thank you for having me. Thank you for organizing the Cloud Native meetup and inviting us. It's great to be here. Thank you for finding the venue in absolutely no time, and of course for Hustle Tree and Surreal TV for basically allowing us to be here. So my name is Pablo. I'm from Brazil, but I live in Amsterdam. I was here for the event, the Civil Navigate event on Kubernetes. So it was quite interesting. Some interesting talks. And the idea is to talk a little bit on cloud native security. What is the landscape? This is a 1 hour talk. So this is why I have the 30 minutes here. So I remember myself that I'm going to be shortening and going faster. I removed a few slides. Let's see how it goes. Sorry for those of you that were at the DevSecOps meetup a few months ago. It's going to be a very similar, actually the same content. I don't think many of you were there. Who was there when I presented? Just you, yeah. Okay. So sorry for that. A little bit about myself. So I basically worked a lot on the search and data analysis, doing ETL, Elasticsearch, Logstash, Grafana, and observability space. I've been 2 years basically focused on cloud native and security. That's the time that I've been working for Sysdig. I'm a developer relations engineer. That's a very fancy title for basically developer advocate, DevRel, evangelist, or whatever. So I create content. I try to enable people, get them to understand. So it's good because I learned myself a lot of stuff in the past 2 years. So I think I can kind of explain it from the basics instead of when you're already like 20 years old in the thing. So a little bit about this talk. I'm not sure how many of you are familiar with the cloud native security landscape, but there are a lot of different acronyms like CWPP, TM, CNAP, what is cloud infrastructure, cloud workload, so on and so forth. So that's the idea, is to go through those and talk a little bit about what they mean and what should you actually understand and care about. So a little bit about you now. So those are some of the acronyms that I'm going to talk about today. So CWPP, CSPM, KSPM, TM, that's not a CM with an S, that's a different thing. That's the one people usually know. CNAP and CDR. How many of you actually know one of those acronyms? Yeah, I know you know them already. So don't worry, don't bother. One, only one. Oh, folks, no, great. That's why I'm here. Good. Yeah, so the agenda is usually a bit longer than that, but I had to short. So I'm going to go through the acronyms and then just talk a little bit about the project that I work on, which is named Falco. Good. Let's get started. So that's the cloud native application. This is the anatomy of it. We have a few important parts here that I'm going to go through. So let's start with the data. That's usually where you run either your database where you put your data in, or you have like a storage, like an S3, right? That's the object storage. You have your management layer with a messaging service, logs, monitoring, where you can see how things are. On the other side, you have the network and security. That's where you can see your audit logs. You can find security groups. You have load balancers, stuff like that. There's also identity and access. That's a really important part, especially nowadays. That's basically where you define who has access to what, right? And again, who does not have to be a person. Actually, we're going to talk about that. Most of the identities are actually not people, not humans anymore. They're just services trying to access another service. You have the platforms. Are we talking about Kubernetes? Are we talking about containers as a service? This is another attack vector. And finally, the workload itself. That's where the application is running. That's usually the bread and butter. That's what you care about. That's what makes your business money. So are we talking about an instance? Are we talking about containers? Are you running on serverless? It doesn't really matter. This is another attack surface. How many here have a security background? How many of you done security before? Okay. How many of you would say you have some security knowledge? All right, the same, no, not the same ones. Yeah, I know you. So the thing about security is every single piece that you have, it's an attack vector. That means that an attacker can exploit that part of your system to get access to something. And because they had access to this layer, doesn't mean from here they can move to another layer. Right? Maybe from this layer, it doesn't make sense to move to another one. But if they are here, they can then have access to other layers, right? So what happens a lot, and we have been seeing, is because cloud native actually brought a lot of different pieces to the puzzle, the foundations are still the same. Like computers, they're pretty much the same as they were many years ago. Things evolved a little bit, but the foundations are there. But we brought more pieces to the puzzle. And with those pieces, basically, we're increasing the attack vector. Right? So I'm going to try to go through some of the attack vectors in here and try to give you an overview of how we see it these days. So I'll start with CSPM. That stands for Cloud Security Posture Management. This is about how good your posture is when it comes to securing your stuff. So it entangles all those different parts. And one good example here is the object storage. So one of the famous object storages out there is S3. Is everyone familiar with S3 buckets from AWS? Yeah. In the past, they used to be public by default right at the beginning. And of course, that became a big issue. People would put data there, and then people would just steal data from it. These days, there's a big button that you need to click. I want it to be public. Then you need to type something, and then it's public. The problem is you might have done something public in there, and then someone comes later and they don't know, or they just put something in there that's actually sensitive, right? So how are you doing against that? Are you checking this? What is checking for you? Do you have automated ways of knowing that your inventory is safe, that your static configs on all of those here are actually good and they are actually securing you? So yeah, that's what CSPM is about in a nutshell. So all your cloud asset configurations, protecting the control plane, tracking cloud resources, we find the static configuration, so on and so forth. Here's some data. So SysData runs a report yearly. Basically, we look into all the user data that we have. So not be as big as a pool as it would be from Google or AWS, but we are doing security. So we really care about this and we look at that all the time, but that's not from me. It was. Yeah. Which one? This one. I guess that was the issue. So the white thing is I couldn't go forward. Perfect. We're back. Yes, we are. So we run this report on a yearly basis. And basically what we look at is from all the user data, or basically what are the attack vectors, what's happening, and things like that. This is actually not from the report, the other ones are, so I just missed myself. So here's some data, you can find it on the internet, like some Flexbook, 3.7 million users data leaked. The Pegasus Airlines, actually, they had like flight schedules, they have like personal information from the crew. Here, audio and video files being leaked. So a lot of very sensitive data being leaked just because it was misconfigured as S3 bucket, for example. So KSPM is very similar to what we just described, like static configurations and posture, but just related to your Kubernetes cluster. So on the Kubernetes layers and levels, like how is your configuration in there? Is it secure enough? We have KM, as I said before, so that's identity and access. Who's accessing what? This is cloud infrastructure entitlement management. 90% of granted permissions, they're not used. That's alarming. 58% of identities, as I said before, they are non-humans. And of those 58, actually 98% of them have permissions that they have not used in the last 90 days, right? This is from our users basically accessing AWS, Azure, GCP, doesn't matter, we are hybrid. And that's just alarming. So least privilege is a thing. You should be worrying about that, and you should be reducing permissions, right? When attackers, they get access to something, either because of a social engineering or because of a leaked key, they have more permissions than they should. And now they're doing worse things than they would because you didn't set things properly at the beginning. So CWPP, it's looking at the workload itself. It's the application. It's how you're running your applications. We're talking about containers. Containers have images. Are those images vulnerable? What are the vulnerabilities that you have in an image? How slim is your image? How bloated it is? How many packages do you have in there that should not be in there? So 87% of container images, they have high or critical vulnerabilities, which is alarming. But at the same time, many of them have a fix available, but were not patched. But not all of them were actually used in runtime. So only 15% of those vulnerabilities are actually loaded into memory. So the library that's vulnerable is loaded into memory, right? And only 2% of those are actually exploitable. And if you don't have a good tool to actually tell you where you should focus your energy on, you're going to be chasing a lot of vulnerabilities that actually are not exploitable by attackers, right? So having runtime data and being able to really focus on what matters brings a lot of value. Other thing, so the image selection is really important. It can reduce the bloat by 97.5%. This is just an example. The same image is 228 megabytes, and you can compare it to the Alpine one, and that's 5.7. So if an attacker takes over a container because of a zero-day vulnerability or any other thing, but they manage to take over the container, if you have Netcat in there, if you have package installer, you're just making your attacker life easier, right? It's easier for them to install whatever packages they need because the package installer is already there. And from there, they can do whatever they want. If they don't have anything in there, and that's how images should be, just running your application and just having the basics, you're going to have way harder time to get things. So what attackers do is usually they use wget or curl to download scripts to run in the machine. If they don't have those, they'll need to figure out how to do it. And it gets way more complex. Yeah, I can skip that in the interest of time. So CDR is my last one. That's cloud detection and response. It's basically, we put a lot of things in place, but bad things can still go wrong and bad things can happen. How do you react to that, right? Since you are in production, you did the CSPM, you did the identity, least privilege, you looked into your images, you did vulnerability management, etc. But Log4j can happen with another library just tomorrow. So what are you doing about that? How are you collecting this data and looking actively at it on a daily basis? Is someone doing something they shouldn't do within my environment? So yeah, companies take about 207 days to identify and about 70 days to actually contain a breach. We're talking about 9 months between an attacker actually taking over one of the pieces in your environment to actually you being able to react and stop it, right? 9 months, that's scary. And attackers are taking more and more time because of the tools and the way we detect things right now is based on what attackers are doing. So if they move slowly, they actually stay in there longer, right? If you move too fast, then you're identified and then people react to you. Good. So all those acronyms, they went into a single one. That's CNAPP. That's Cloud Native Application Protection Platform. And no, I don't know them by heart. I read them all the time. I kind of know what they mean when I look at them, but yeah, you get it over time. So CNAPP is basically, you can have different vendors provide you those different pieces, right? But why can't you get a single vendor or a single solution to actually offer you everything all together from CSPM to CDR, right? So that's what CNAPP stands for. It's a thing that SysDig has been talking for a few years. And at the beginning of the year, Gartner released a report basically actually stating that CNAPP is the new thing and that companies can cut a lot of their costs by actually going to a single vendor. And yeah, so people have been talking more and more about that over time. So the way I like to see, that's a good summary. That's going to be recorded. You can have the slides later. But yeah, it's all under CNAPP, and basically each one of those matter in a different way. Any questions so far? No, I start with? No, okay. Fine. Yeah, okay. All right, so now is the time that usually I go talk about the different attack vectors, and we really go into the different verticals and places that attackers could actually go through. I don't have the time for that, so I'm going to jump directly into runtime security. So what is runtime security? Runtime security is within CDR, cloud detection and response. It's basically after you have all your security layers put in there, you can still have an attacker doing bad things. So how can you look into that? How can you detect that? And how can you react to that? So that's what runtime security actually is. One of the tools that you can use that's open source and that works really well in the cloud native space is Falco. So Falco was created by SysDig many years ago, and it was donated to CNCF many years ago as well. So now it's not a SysDig project anymore. It's actually a CNCF project. And it is the runtime security project. It helps you do threat detection within Kubernetes, hosts, and cloud. Basically, some common threats that you can look into, like outbound connections. Is your container connecting outside and getting data from outside? This might be something you don't want to happen. Is anyone opening shells into containers that you have? Not sure if you open shells into production containers, but you shouldn't. Like, that's not a good practice, and that should be avoided. And if someone is doing, even though you could be a developer from your own company, you want to know about it, and you want to be able to go to them and say, hey, don't do that in production unless like you really, really, really need to. That's not a good thing to do. That put us in danger. Crypto mining, people take over, just run crypto mining. Actually, I was reading a report yesterday about how much money companies were actually spending extra on their bills with those cloud organizations just because of crypto mining. It's like insane. So Falco has been an incubation level project for a while. In CNCF, this is level 2. And we have applied to graduation last year. We are waiting for a response, hopefully in the next weeks before KubeCon, otherwise going to be at the end of the year. And that basically states that the project is getting more and more mature over time. It's getting more and more traction. Just to give you an example, we just got a new maintainer, a core maintainer that's from Apple. Apple is running Falco in more than 90,000 nodes in their infrastructure and really collecting a lot of data and doing analysis on a data lake. Their use case is quite interesting. Good. So the Falco ecosystem, Falco works in 2 different ways. One way is to do host security in what I've been talking about. So we collect data on the host that Falco is running. The other way is kind of what I call cloud security. So we collect data from cloud. Kubernetes audit logs, that's from the cluster. Okta logs, that's from like your Okta that's running your organization. CloudTrail logs, those are AWS logs on what people were doing within different systems. GitHub, like those are webhooks that are actually feeding data into Falco, right? And this is collecting data from system calls. That's what's running on the host. I'm going to talk more about that in a bit. So within Falco, you can output to different places. One common one is Falco Sidekick, is a younger, broader project within the Falco security repository. And Falco Sidekick has integrations with a lot of different common platforms like Slack, Elasticsearch, PagerDuty, and you can do things like, oh, if priority is greater or equal to critical, then send me a PagerDuty because I want to be able to react right away. So on the system call side, not sure how many of you go really to like low level in system call things. So I try to just give you an idea of how it works. This is a big new thing on cloud native. You probably heard about it ETF before, even though you don't know about it. But you have the kernel space and the user space, and everything that's running in user space when they need to access any hardware stuff like sockets, memory, whatever, they need to go through the kernel to do that, right? So every process needs to run system calls to access system resources, right? So containers are processes, Kubernetes processes, everything runs within a process. So everything that's running in the same host needs to go through the same kernel with the same system calls, right? So what we do in other projects as well, but especially using the VPF or the kernel module is we hook into the kernel, we sit there and we say, every system call that happens, I want to take a look at it, right? And taking those system calls, we can then do a lot of nice stuff, basically saying, oh, is the system call matching the list of suspicious things that I have? Yes, then I send an alert, right? And those suspicious things are rules. And I'm going to talk more about that in a bit. So yeah, let me go to a demo. I think I probably have another 7 minutes. I hope. Plays out the blocks without us having to wait too long. So the demo that I'm going to do, it's a Log4Shell demo. So there is an attacker. The attacker is going to start a malicious server. It's going to send a malicious payload to the vulnerable server with the log4j running. What log4j is doing, every time you try to log in and the login fails, it logs the username. This user failed to log in. With the malicious payload, this actually is going to force log4j to go and look into this LDAP, which is my malicious server, which is going to send a malicious response. That's a Java class that's going to be executed by the server. That's the exploit. And then it's going to send a request of, actually, it's going to execute whatever I want. What I'm sending it to execute is a netcat. That's a reverse shell to my open netcat waiting. So I have the environment here. It's running. Sorry, I have a lot of things with Zoom. So is that big enough back there? Can you see? No. Bigger. You can just say bigger, it's fine. Is that good? Yep. Yep. All right. So this is my cluster. I'm the person taking care of the cluster, running stuff. Account portal is one of the applications that I'm running. This is my login page. And now I'm going to go to the attacker. I have 3 tabs for attacker. This is not the same machine. If I try to run this is going to fail. Like it's a separate machine. So from an attacker machine, I'm going to start the LDAP server. That's the malicious server. From the attacker 2, I'm going to start a netcat listening to 9001. That's me waiting for the reverse shell. And in the attacker 3 tab, I'm going to just create the payload. What I'm actually running is a netcat to my own IP, the port that I define it, opening a shell. That's what I'm doing. I'm going to copy this payload. I'm going to go to this page. I'm going to paste, and I'm going to log in. And it's going to fail. And if I come here, boom, I'm in. Okay, that's the log4j exploit just here, right? So from here, as an attacker, I can start doing a lot of bad things. I can start poking around. Of course, I planted a secret in there. So some people, they actually just forget important files where they shouldn't forget them. And this is the configuration to the Kubernetes cluster within the container. That should usually not happen, but it did. So if I do kubectl get pods, this is going to fail. Then what I'm going to do is I'm going to create this config file with the config credential that I just stole. And now if I do get pods, okay, I don't have anything in the default namespace, but I have full access to the cluster. The cluster is running Falco, right? So I had some protection. As an attacker at this point, I could try to just stop Falco if I have access to that. But yeah, I'll just keep it running for the sake of the example. So I am in the attacker 3 tab. I'm gonna open a shell to that container. It could be any of to the pod. It could be any of the pods. Within there, I'm gonna download XMRig. This is for crypto mining. And then I'm gonna start the crypto mining, the XMRig binary, and just run it. I kill it, otherwise it's gonna consume all the CPU in my demo, and that's not what. Any questions about the attack?
How many minutes do you have done?
How many what?
How many crypto coins do you have?
No, I stopped them right away. Do not get in trouble with them as well. That's another reason. So yeah, so here we are. That's a Falco Sidekick UI. I don't expect you to use it in production, but it allows us to see things in rather quickly. So those are the different events that happen. They are all coming from system calls, and those are the different priorities. One of the things that I did was run Falco Sidekick with a Slack. So one new message, critical executing binary, not part of base image. And here's all the details. So I got the Slack message from someone executing a binary that was not part of the base image. If I go to events, now I'm actually going to zoom out. I'm going to walk you through. And you can look into things from the beginning, from the first netcat remote code execution in container. We have some redirects that happen in terms of outbound connections. We have a remote file copy tools. That was the wget that was running in there. We got the other, like a right below root that I did, that I basically downloaded the file under root. And then the drop and execute new binary in container. This is a very interesting one. Basically, when you're running a container, you have an image, and that image has the base layer. That's the image that you're running. Anything that you add on top of that on the operating system level gets a flag. That's the execution layer. It's actually true. So it's not part of the base image. And that's what we use like here, like the upper layer, exact upper layer. That's the flag that we have. And that's the flag that we use to actually find that. I could talk way more about Falco. Unfortunately, I don't have the time. If you're interested about this, just come talk to me. I could show you the rules on how to actually write this. They're pretty simple. I can show you some other inputs, but yeah, I guess that's what I had, and hopefully I didn't blow time that much. Okay, thank you for having me. And yeah, if you have any questions, just let me know. Well, I guess the next speaker, you can probably start setting up. Okay.
8-minute break.
Okay.
Thank you.
Yeah, I do. Sorry for that. Thank you for coming.
Hello. So my name is Alex Kirkhoff. I work for Akamai now. I used to work for a little bit about myself. Oops. A little bit about myself. So up until a few months ago, I was a founder and CTO of a cloud-native storage company called OnDat, and we recently got acquired into Akamai. And I also have two hats for today because I'm also the co-chair of the CNCF storage tag. So we are the technical advisory group that help advise the CNCF on storage-related matters, and therefore we also help curate and do due diligence and provide educational material in the storage space for all the storage projects that are in the CNCF. A little bit about Akamai, in case you're wondering. They are the world's largest CDN and network provider. We have something like 500,000 servers spread around all of the globe, providing most of the TV and just about everything that you use on a day-to-day basis. We're currently peaking at around 1 petabit, which I find very exciting. If you're doing mental maths, that's 1 million gigabits every second. So I find that pretty cool. But also, what's also really cool here is that Akamai bought also acquired Linodes, which is a small cloud company. We're in the process. We're in the process of expanding into 10 new data centers this year, and we're currently building some really new and fun storage systems. So feel free to ask about that too. Now, I'm putting this as a bit of a plug. The CNCF storage tag is open. We'd love to hear about your use cases, and if you're involved in any projects that are storage related, we'd also like to hear it. But also, we'd just like to hear people who are using cloud-native storage and help contribute technical expertise. So I was very happy to see that some people were already using cloud-native storage and had cloud-native stateful workloads. So feel free to join the calls. All the calls are open. And we'd love to have more contributors. So cloud-native storage is a really, really big topic and very hard to condense into 30 minutes. So I'm going to try and give you some of the salient points and also sort of give you some pointers to some of the things that we've done in CNCF to help in this space. But why should we be thinking about it? Because the thing is, we often say, well, isn't Kubernetes stateless? No, containers stateless. But the thing is, there is no such thing as a stateless architecture, right? Every single application in the world is storing state somewhere, whether it's in an event queue, in a database, in an object store in files. And it's kind of trying to understand how we manage those stateful components of our applications. I speak to many people today that have parts of their application running in Kubernetes, but have databases running in VMs, or they're consuming databases as a service, for example, from a cloud provider. And that's fine as well, right? But the thing is, we've put a lot of effort typically into our Kubernetes environments. We have self-service, declarative configurations, automatic failovers, all of the policies and security scanning and everything else that we've built into our system. And yet we're not using that for maybe the most critical parts of our applications where we're actually storing data, or we're actually persisting the data, right? So we can obviously use all of the goodness that comes with Kubernetes and all of the things that we've invested in the Kubernetes environment to apply to stateful workloads too. And yes, you can run databases and key-value stores and object stores and storage systems in Kubernetes too, and get the scale and failover and performance out of those systems. So when we talk about cloud-native storage, and this is kind of a bit of a clarification thing, when we think about storage, and if I ask lots of people about storage, they think about volumes, and that might be block storage or file systems, for example. But in the cloud-native space, storage means anything that you can use to persist data. So that also means systems that you access over an API. So key-value stores and object stores and databases are also part of the cloud-native storage ecosystem. In order to help clarify a lot of this, because there's a huge amounts to it, we put together the CSF storage white paper. So this has been an effort that's had lots of contributors contribute paper. It's available on that link. And we can, and in that paper, we discuss, some of the basics like the terminology, but ultimately what we're trying to do here is to enable developers and application owners to understand what goes into a storage system, both in terms of the layers that make up the system and therefore, actually contribute to the different attributes of the storage system. And why is the attributes important? Mostly because for the longest time, developers haven't had to worry about storage. Storage is something that an infrastructure team or a DevOps team put together. You ask for a volume, you ask for a database, you got the database, and that was that. But in this new environment, in this new cloud native environment, developers aren't doing self-service. They're actually building their own databases, they're building their own systems, and they kind of need to know what they want out of what they need from their application in order to define what they need out of the storage system. And that also influences how you deploy it and the management interfaces. So, for example, the CSI drivers in Kubernetes and the access interfaces, whether you access over an API or a file system, shared file system, or whatever. So, when we talk about storage attributes, these are the main ones that we think about. And these are the most important ones that we should know about when we're planning a system. Availability is often one of the most important things. And availability is about, is the system there to service requests when you need service requests, right? And availability is often measured in terms of the number of lines. So you can say it's 4 lines available, which is 99.59% available. And that kind of translates to 52 minutes of downtime a year. The important thing about availability is it available in all the places that you need it? And can it be available when different parts of the failure domains fail? So, for example, you might be worried about failure of a region or failure of availability or failure of just a host, right? Depending on whether you're doing this in your own data centers. Scalability is also an important thing, right? You might want to scale a huge amount in terms of the number of operations that your database can do, in terms of one host accessing one disk, for example. But you might also have applications where you have tons of clients all accessing a set of APIs, and it's about how many clients you can support in parallel. And then that kind of leads to the performance aspects. So the key performance differentiator is often the latency, and that kind of does determine the throughput and the number of operations that we can do. In some cases, different applications need to optimize for different performance metrics. So, for example, if you are a transactional database, it's all about having the lowest latency and the most number of operations per second. But if, for example, you're doing machine learning or you're doing some sort of data warehouse, you might really focus on throughput. It's about the number of megabytes per second or gigabytes per second that you're pushing through the system. And the number of operations might be lower because you're accessing the data in much, much larger chunks. Consistency is also a factor, and this kind of affects a lot of the other systems in terms of both the availability, scalability, and performance and durability. And consistency is kind of two things here. It's important not to get them mixed up. One is when you store data to a system, when is it available, right? There are many distributed systems which, for performance reasons, might optimize for eventual consistency, where you might commit a transaction, but it might only be available some short period of time afterwards. That might be okay for many applications, but it might not. And if you're a bank, for example, and you've committed money into an account, you want the accounts to be up to date instantly. And then there's also the difference between when data is synchronized to a physical store, i.e. has been persisted, or whether it spends a certain amount of time in a cache, for example. And sometimes you might want to take those sort of compromises to say, I want to have data stored in a cache first because that's the only way I can get my IO per second. But now you need to make sure that the data is adequately replicated, because obviously if you lose data, if you lose a node or you lose a cache, then how much data do you lose and what period of time do you lose? And that finally kind of takes us to durability. So durability is always a factor of what will it take to lose data in a system. So you often measure durability in terms of the number of replicas or the amount of erasure coding that you do in a system, which is again another way of having multiple copies of multiple parity sets of data. So if you lose one of the nodes or you lose one of the disks or you lose one of the data sets, you can still reconstruct data from the remaining data sets. I had versions of the slide where I compared different cloud provider storage systems against some of the metrics. And I thought that would probably get me into trouble. So I'm going to talk about it instead and just use this as a prop. So if we look at something like EBS, which a lot of people are familiar with, EBS has really good availability, but it's only available on one server at a time. And it's not available across availability zones, for example. So that impacts how you deploy your application if you're using EBS. It has extremely good performance because it's very low latency and can support lots of IOPS, although that can be expensive. And it's obviously got good data redundancy within an availability zone. So you need to think of your failure domain as an availability zone when you use EBS. And EBS is a block volume, which means that you can mount it into your nodes. If you're running Kubernetes, you can have a CSI driver that can mount those EBS volumes into your node. And then a file system is put on top of it through the CSI driver, which you consume in your application. You can therefore use that to run your database on an EBS volume in Kubernetes. Another way of doing this would be to use shared file systems like EFS. So why would you choose that, and what are the different attributes? EFS is replicated and available from multiple clients at the same time because it's a shared file system. So it's more useful, for example, if you have a single writer with multiple consumers consuming the data, for example. It's also, because it's replicated across availability zones, you can use it across your application that doesn't have an availability zone failure domain anymore, and you can use that across multiple availability zones. The consistency can be a bit of a problem because implementing locks on a shared file system that are honored across a distributed infrastructure is obviously very, very expensive. So you also, because you have this distributed file system, you also have higher latency. But you can get faster throughput. So EFS is terrible for running a database on, but exceptionally great if you want to do, say, machine learning or some sort of data warehouse type workload, because you can ingest a lot of data and export a lot of data very fast. And then finally, S3. So everybody's probably used S3 in some form or some type of object store on one of the cloud providers. S3 is available through an API. It's incredibly available and incredibly durable. It's probably, famously, S3 has 11 nines of durability. And if you're interested in what that means, it's about 3 trillion chance of losing data, which basically means that there's a higher probability that the sun implodes before you lose data, which is obviously nonsense, right? So this is basically like when cloud providers claim 11 or 12 lines of availability, which some cloud providers do, it kind of means that your data is in lots of different data centers, lots of different availability zones, lots of different disks, and lots of different hosts. And statistically, it's impossible to lose data. That is obviously very different from the data actually being available, because for the data to be available, the right networks and the right components still need to be talking to each other, right? But S3 does give you an incredible amount of scalability, and it can be accessed through an incredible amount of systems, right? So S3 and object stores in general typically have the largest capacity systems in the world. I think Amazon's largest object store client has 600 petabytes of data in a bucket, which is insane. And some of Amazon's buckets actually span over 1 million physical hard drives. That's to kind of give you an idea of the physical amount of scale. However, the API overhead of the HTTP REST request and the signatures that involved in the ACLs per request mean that there is a higher amount of latency. So whereas a read or a write transaction on an EBS volume can be sub-millisecond, in the case of S3, it could be 40 or 100 milliseconds, right? And that means, again, it's absolutely great if you're accessing lots of things concurrently from lots of different places, because you can get high throughputs from the concurrency, but it's especially bad if you're trying to use it for databases. That said, there are lots of databases now that have S3 and object store plugins because they're using them for analysis and other correlation vector databases and things like that. Okay. We also talked about a little bit about the storage layers. So I'm kind of going to whiz through this. The point that I wanted to highlight with the storage layers is that storage systems are complex. There's a reason why storage systems iterate much less slowly than, say, compute or networking. And the reason is that a lot of the things that we're talking about for distributed consistency and distributed systems are still hard computer science problems. And there aren't like a ton of very easy open source systems that can do this. So what we end up seeing is that we build storage systems by having different functionality and different layers in the stack. And understanding some of the layers that go into your storage system, if you're deploying your own database or you're deploying your own object store, for example, is kind of important because it helps you define the attributes by understanding what's happening in each of the different layers. So, for example, in a time not too long ago, when everybody built stuff in data centers, you would judge the attributes of your storage by the way you accessed it. You'd have a SAN, and that would be low latency because it's block storage. And you'd have a NAS, and that would give you shared file systems because that was the way NAS worked. And that kind of gave you some indication of what the capabilities of your storage systems are. Now you can have a file system that's built on top of an object store, or a database that's built on top of a distributed file system. And therefore, the file system carries the attributes only of the file system, but it also has the attributes of the S3 system or the object storage system underneath, right? And therefore, this is kind of important to understand if you need the latency or the durability or the availability of some of those underlying components. And it comes into play when we're looking at how replication or encryption works as well. So understanding the security elements of it and what layer in the stack that is happening. So we talked a little bit about performance, and performance is one of those, is another one of those things that we've been working on in the tag. The link there is to a document that we're still working on and still contributing to. And we're looking at, we kind of said, once we describe the attributes and gave, developers an understanding of what the differences were, we wanted to delve into detail of each of those individual attributes. And performance was going to be one of them because that seemed to be the one that came up the most often. And what we discussed is performance of databases and performance of volumes, because those were the things that came up the most. And we were discussing some of the things, that I just mentioned, like, for example, the difference between being able to do lots of operations versus lots of throughput, which are often diametrically opposed, right? You can only do lots of operations if each operation is a small amount of data, which inherently means you can't do a lot of throughput. And obviously, if you want a lot of throughput, you need to do a smaller amount of operations with a larger amount of data. But the number of operations is limited by the latency of the system. And so that kind of ties in. So latency often matters more than some of the other things that you factor into the system, like the topology, whether it's sharded or hyperconverged or replicated or distributed, or the encryption requirements, for example. The latency option is the biggest determinant there. But also the concurrency. So when you want to do lots of operations or lots of throughput, often a factor is how many clients and how many systems can be doing those in parallel, right? It's very easy, for example, to do a lot of operations if you have 100 clients and they each have 100 connections connecting to different API endpoints. But it's really, really hard to do it if you have a single client with a single connection, for example, in which case you're completely serialized and the latency is the only determinant factor there. The other thing to consider is caching happens at every layer of the stack. If you think about a typical database query, it could go through one or more Redis or Memcache or whatever your favorite caching system is. Talk to a database that might have a chunk of shared memory dedicated to the cache, which is then talking to a file system which has a bunch of pages allocated to the buffer, which is then talking to the storage system, which has a bunch of pages allocated to the buffer, which is then talking to the NVMe disk, which might have a bunch of cache in the hardware. So all of those things do play a factor. And that kind of leads us to one of the most important takeaways. Because of all of those different layers, and because it is so complex, it is generally useless to take the performance numbers that vendors give you. When they say, we've given you the fastest database, blah, blah, transaction per second performance, that is generally not very helpful unless you've actually tested it yourself in your environment, in your cloud system, with your network, with your storage, with your own applications, because it is just so very different and so very hard to do benchmarking unless you're testing apples for apples, and only your system is generally unique to yourself, right? So the reason why I say that is, if you have a look at the documents, as we were writing it, we kind of came to the conclusion that so many of these things are really, really hard, but there's probably more caveats in that document than there is actual guidance. And the caveats are actually very, very informational. So I'd really suggest having a look and also, contributing comments. But of course, kind of rewinding back to the beginning, we kind of said, okay, so what does cloud native storage give you to your, what are like the benefits? Why would you choose to do this? There are the obvious benefits of being able to automate failovers and having a declarative interface and kind of building your own database as a service or message queue as a service. But also, in your Kubernetes environment, you kind of get a lot of systems when using cloud-native platform like Kubernetes and a cloud-native database. You kind of move to a new paradigm where data stores provide a level of availability and a level of failover across a number of nodes, which means that you're no longer in the traditional business continuity and disaster recovery paradigm where you have, say, an active passive system. You now have active environments that can fail over automatically. Where humans don't have to make manual decisions to hit, to run a failover script, for example. All of these things can actually happen. And we have, if you look at this final document, which is one of the other documents that we've just done in the tag, we cover a number of disaster recovery reference architectures and provide systems. And we've actually done demos of this where you can have, for example, replicated, three-way replicated environments sharded in 4 different regions, for example, and have data consistency and failover across regions and failover across sites in a very, very automatic way using off-the-shelf open source components. That doesn't mean, by the way, that this is like super easy to do. This still requires you to follow best practices and to make sure that we're not doing silly things and introducing single points of failure in the stack. But it is eminently possible to do things that just 10, 15 years ago would cost you the better part of $1 million in storage hardware and specialized, clustering software to do. You can now do it for, $50 or $100 a month in manage your managed Kubernetes service of choice in some open source. This is kind of game changing, right, for these sort of environments. In the CNCF, there are a number of different storage projects that kind of fit into the system. In the CNCF, we have three classes of projects. There's the sandbox project, and there are a ton of them. If you look at that link there, in the storage space, covering everything from local volume managers like Carina to or OpenEBS, for example, as well as a variety of different file systems. But I'll talk a little bit about incubated projects and graduated projects. Incubated projects are projects that actually have, ironically, although it's not intuitive, incubated projects in the CNCF have the largest amount of due diligence applied to them. So incubated projects means that somebody like myself in the tag and the TOC will have interviewed actual end users, found out about real life use cases, made sure that there's good governance in the project, there are a number of different maintainers and things like that. And that's what gets you incubating status. Graduated projects have one further level or two further level steps, which one is security audits, and the second is that they have a more thorough governance model. So, for example, they have maintainers for multiple organizations, right? So things like Kubernetes, that's a graduated project. And therefore, some of these, for having some of these storage projects arrive at graduation means that they've actually been through a lot. They're in use in production. They have real big workload on them. You can look at the due diligence stocks and see sort of who's using them and the types of use cases. And we have systems like Rook, which provide an operator around Ceph, which is a distributed file system, an object store, and a block store solution within Kubernetes. It does have a bit of a learning curve, and it does use it does need a lot of work, but Rook does do quite a good job at simplifying things. Vitess is a database project which actually spun out of YouTube. This is a way of creating giant MySQL clusters. So, for example, in YouTube, they actually have single database instances that are sharded over 10,000 nodes. And Vitess provides Vitess is also covered by the company called PlanetScale, in case you might have heard of them. And that project gives you the ability to run these large replicate and sharded databases. Harbor provides container registry and registry caching capability. etcd, you've probably all heard that. It's replicated strong consistency protected by Raft key value store, which is sort of the core of every Kubernetes installation. It forms the config for every cluster. PIKV is a distributed, replicated key value store. It's based on a RocksDB foundation with Raft across the top. It's extremely powerful, extremely fast, and is also the foundation for another project that's going through the system, which is called TIDB. I never know how to pronounce these. TI is actually short for titanium, so it's technically titanium, but and that's also a really, really interesting project. Another two that I'll mention very quickly is Kubefest, which is a nice new distributed file system, really great for workloads where you have multiple consumers, multiple readers. So it's really, really great for data warehouse type solutions or ETL type solutions where you're processing lots of data. It's not PostGIS compliant across the file system, but it is PostGIS compliant from a file. which means that you get those that sort of lucky semantics in the file. And then there's Longhorn, which provides, which is a project which was part of Rancher, now Suzy, and that's a distributed block storage system, which incorporates things like snapshots and backups of the volumes and can run within your Kubernetes environment. So you can kind of get hyperconverged replicated volumes within your Kubernetes cluster. So that's a little bit about those projects. I'll briefly talk about some projects that I'm going through at the moment, which I'm also very excited about. I'll start from the bottom. So ProPushDB and Gigabyte are really, really great, and they're covered in the Cloud Native Disaster Recovery paper. So they are fantastic at providing those replicated databases and sharded databases with strong consistency across multiple regions. TIKV is a project that we're using, that we've used internally, and we're also building additional projects over. It is insanely fast because it's using tuned version and a sharded version of RuxDB. So, you know, things like a million puts or a million transactions per second on a cheap $100 5-node cluster is eminently possible, and done that in real life. It's insanely fast. And Cloud Native PG is also another project which is incredibly exciting, which is it's being introduced as a sandbox project now. And Cloud Native PG gives you a cloud native operator for Postgres. So effectively, you can now create a custom resource that defines everything that you need out of the database, and Cloud Native PG instantiates the master and the replicas and the replication of failover automatically. And it's the same product that EDB, who are one of the biggest maintainers for Postgres, are using internally for their own database service. And then finally, and I'll stop there, try out Node and try out Akamai. Some of the new things I've built because similarly, I would get a kicking from our marketing team if I didn't say something. That's it. That's me. Yeah.
So many of these, the essence of many of these projects are just function, like virtualization of storage functions.
Some of them are, yes.
Yeah. Do any of them reuse or extend some basic protocols that are used, say SAN, for example, iSCSI, things like that? Do they get inspired by it, or are all of them reinventing that?
So some of them use proprietary protocols, some of them use existing protocols. There's a lot of block storage projects, for example, that are based on the SPDK, which is the well-known library that uses the NVMe over fabrics, and that kind of the next evolution of this device level. But yes, perfect.
Sorry to interrupt, but we have to leave soon, so I have to cut it short, unfortunately. But great to see everyone, and hopefully we'll be back in our usual venue with more space next week.